Hi everyone, I'm Arun. So today we're going to present about lab 2, which is three-phase balanced pure load in delta configuration. And this is my teammates Clara, Muhammad Fazli, Lukman Hakim, and Muhammad Faiz.
Good morning, and I'm Clara Sari. Today we are going to discuss Lab 2, which is three-phase load connected in delta configuration. The learning outcomes for this lab, which is at the end of this lab session, we should be able to demonstrate the theoretical aspect of the operating response of the complex load in an AC and three-phase power system. Secondly, we should be able to investigate and compare the characteristic of pure individual load of a resistive, inductive, and capacitive in three-phase balanced load system with the star configuration. So for this lab, we will start with part 1, which is balanced resistive load, which will be explained in the next slide. Thank you.
Hi everyone, I'm Arun. Today I'm going to present the setup of the balanced resistive load. So first, connect the resistance delta configuration set to 750 ohm and switch on the variable three-phase power supply and set the phase voltage to 230 V. Okay, record the following result. So U12 is 398 volt, current is 0.9 ampere, power is 208 watt, Q1 is 0, reactive power is 0 VAR, apparent power is 208 VA, power total is 628 watt, reactive power is 0 VAR, and apparent power total is 628 VA, and the power factor is 1. So record the reading. We record the reading uh, from that circuit. Okay, and then compare the values to those measured in star configuration. In star configuration, which of the following statements are true? The cause factor increases is wrong. The current in the phase doubles. Which of the following are true? So the power is multiple by 3. This is the answer. Okay.
Hi and Assalamualaikum. My name is Muhammad Fazli bin Husin, B081810176 from class S1 stroke 2. So, for this lab 2 part 2 balance inductive load. So, for the first step to do in experiment, first set the following circuit as in figure 5. So, you must follow all the connection as, as shown in the figure 5. And then compute the maximum line to line current I1, the phase to phase current is 0.65, and then by using the formula I max equal to square root 3 multiplied by I, TH max. So for the second step, switch on the variable transformer and set the line to line current to 1 ampere, and then must using the formula reactance XL equal to XL over I2, and then record all the following result by measure the following variable and compute the reactance XL of the circuit. So this is our result, and then for the 1.2 Henry U1N, we got 118 volt, U12 205 volt. For the I, we got 1 ampere. For the P, we got 14 watt. For the Q, we got 117. For the S, 118. P, 43. And the QT, we got 353. For the ST, we got 356. Cos theta 0.12, and the last one XL 352. That's all for the result part 2 balance inductive load.
Okay, Assalamualaikum. I'm gonna explain about the part 3 balanced capacitive load. Okay, this is figure 6. We're gonna build the circuit. Okay, experiment procedure number 1. Set up the following circuit as in figure 6. Okay, like the figure 6 one. Okay, 2. Connect the capacitive loop in delta configuration and set the capacitance to 2 microfarad. Okay, number 3, switch on the variable 3-phase power supply and set the phase voltage to 230 volt. And then lastly, we're going to measure the result by record the following all the measurement. Okay, measure the following variables corresponding to the different settings and compute the reactance at C of the circuit. Okay, the table shown below. After we have measured the everything that we need, we can get the voltage phase, I phase, reactive power, and so many things. Okay, but for the reactors, we must use the formula, that is at C equal U phase divided by I phase. Okay, the result gonna be 230 volt divided by 0.441 ampere. Okay, and the result, the answer is 522.73 ohm. That's all from me. Thank you.
Hi, I'm Wak Faiz. Now I want to share further conclusion about this delta configuration. For the conclusion, we are able to demonstrate the operating response of the complex load in an AC and three-phase power system for the balanced resistive, inductive, and capacitive load for the delta configuration. We also can compare the characteristic of pure individual load of a resistive, inductive, and capacitive in the three-phase balanced load system with the star configuration is more detailed when they conduct this experiment. The experiment different with the star connection is in terms of the schematic circuit and the formula that used to find the current line. For example, to get the line current for the star configuration is equal to the phase current, but for the delta configuration, the line current is equal to the root 3 time of the phase current. It also different with the formula to get the phase voltage.